Today's lesson 2.2 is how to solve and graph inequalities and write and solve compound inequalities. Quick overview, remember your inequality signs. If we're reading from left to right, in this case this would be greater than because it's bigger here. Remember that the line underneath represents or equal to, so the second one is greater than or equal to, versus these bottom two. The smaller side is to the left, so that's less than. And the very bottom one is less than or equal to because of the line underneath. Couple things. When we are graphing these, if we have an inequality, x is greater than 4, and notice the way that I'm reading this. I'm reading this from the perspective of the x. So some number x, I don't know what number it is, but whatever it is greater than 4. If we're going to graph this, I am using an open circle because I do not include 4. It says greater than 4, not greater than or equal to 4. So my solutions are going to be any number that is greater than 4, not including 4. For example, 4.1, 4.2, 4.3, all those numbers work. Those are acceptable solutions. They are all greater than 4. So use an open circle when you do not include the number. And in the second example, when I want my solutions to be greater than or equal to 4, then I use a closed circle to represent that 4 is part of my solution set. Okay, compared to the last two, again, this is x is less than 4, so I am drawing my line to the left of 4 to represent all the solutions that are less than 4. And my final one is less than or equal to 4, meaning again all the numbers that are less than 4, but now I have a closed circle to represent that I am including 4 as well. Let's try some practice. We are going to solve and graph these inequalities, and this is the same as solving any other equation with one exception, and that's written at the top. So if you're taking notes, make sure to write this down. You want to make sure that anytime you divide or multiply by a negative number, that you flip the sign, flip the inequality sign. So instead of writing equal, greater than or equal to, you would flip it to be a less than or equal to. And I'll show you an example of that with these two problems. Okay, so like I said, in order to solve these, we go ahead and solve them as we would any equation, and that would be to distribute the negative 2 into the parentheses. We would get negative 2x minus 18 plus 5 is greater than or equal to 3. Let's combine the like terms on the left side of the equation. So we'll combine the negative 18 and the 5 to get negative 13. Now let's go ahead and combine our like terms on the same sides of the equation. So let's move the 13 to the other side, and we will be left with negative 2x is greater than or equal to 16. Okay, our final step then is to divide both sides by a negative 2, and this should ring a bell in your brain right now. We are dividing by a negative, and if you remember that note on top with the star, anytime you divide or multiply by a negative, let's take our sign and let's flip it. So now we have a less than or equal to. On this side we are left with x, and on the right side we are left with negative 8. Okay, that's our final answer, and we remember to flip our sign right here. Okay. In order to graph this, if you don't remember, we need to only plot one point, so it's kind of nice. We are going to plot the negative 8, and I need to have a closed circle because it's less than or equal to negative 8. So I'll make a closed circle here at negative 8. And then I just need to draw a line either to the left, showing that I want solutions that are smaller than 8, or to the right, showing that I want solutions that are greater than 8. If I look at my equation, it says, and I'm reading from the perspective of where the x's have to be less than or equal to 8. That means then that I want all numbers that are smaller than 8. So I would put my line to the left. Okay, and in our second example, let's go ahead and solve this one. So what I would need to do is add 18 to both sides. And I would be left with negative 5y is greater than or equal to 70. Then I need to get rid of the negative 5, so I'm going to divide both sides by negative 5. And again, your brain should be thinking, we just divided by a negative 5, so I need to flip the sign. So instead of a greater than or equal to, I'm going to have a less than or equal to. So I will have y is less than or equal to negative 14. Okay, let's graph this. So I need to put a circle at negative 14, and if you'll notice on this one, it is again a less than or equal to sign, so we'll do a solid circle. And I've drawn my own graph because the top one does not have a negative 14. We will now plot a line. This says we want all the y's that are less than or equal to. Well, the values that are less than negative 14 all go to the left as well. All right, so that's a review on how to solve and how to graph your inequalities. Let's move on. Okay, we're going to be doing some contextual examples. In this first one, the cost of a field trip is $220 plus $7 a student. Right now you're thinking to yourself, I know how to graph that because that's a linear equation. So let's go ahead and make an equation out of what we just saw. So the cost of the field trip is going to be $7 per person. So we'll say that's 7p, and we'll identify p as our variable, and we'll represent that as the number of people going on the field trip. So we have 7p plus 220. $220 is a one-time fee, and then we pay $7 per person. Normally you would say that would be equal to y, but in this case, if we read on in the problem, then we can see where the inequality comes into play. The school can spend at most $500. That means that they can spend up to $500 and $500, but no more. So let's go ahead and put $500 out here. What we are doing is comparing the left side to the right side. This is what it costs, okay, and we can make a note here. This is the cost of the field trip. And this right here, this is our budget. This is our max budget. We cannot spend more than $500. So all we need to finish this problem is an inequality sign. And we have to think about what this is saying. We can spend at most $500. That means that this side has to be less than or equal to $500, but it cannot be greater. This problem says how many students can go on this field trip, so we would want to go ahead and solve it. We would do that by subtracting 200 from each side. Let's choose another color here, or 220 I should say. So we would take 220, subtract from each side, and we would end up with 7p is less than or equal to, let's see, that would be 280. And then we would need to divide both sides by 7. Do that there. And our final answer, and let's do that in red, we would say that the number of people that can go on this trip has to be less than or equal to 40. Okay, so there are 40 people at max that can go on this trip, up to 40. All right, let's look at our second problem. In this problem, you measured a space in your apartment for a small couch, and you determined that the perimeter, the distance around the couch, must be less than 102 inches based on the space you have. You also know that the length of the couch must be 42 inches greater than the width. We need to just describe the dimensions of the couch you need to find. So we're going to describe that as an inequality. Well, first thing we need to do is define perimeter. Well, perimeter, remember, is equal to 2 times the length plus 2 times the width. That's the equation for perimeter. We also need to define some other things. We need to define what the length is, and we need to define what the width is so we can have something to plug in here. Well, let's just use our width first, since they're not defining our width as greater, 2 inches greater than the perimeter or the length or anything else. So what we can do is we can just say that the width is going to just be equal to W. Now let's define the length. Well, our length, they're telling us, is 42 inches greater than the width. So if we take the width and add 42, that would give us our length. Now we're in a good position to write out the perimeter. Well, the perimeter is 2 times the length. So let's do a 2 here. 2 times the length, which is W plus 42, plus 2 times the width, and we just said the width was W. So what we're saying is that this is the perimeter of our area that the couch needs to fit into, and we are saying that the couch must be less than 102 inches. So we have 102 over here. Okay, and if we do like we did on the top one and we say, okay, this is going to be our couch, the dimensions of our couch, and this is the area it needs to fit into. Area to fit. So what would our inequality be in this situation? Well, this has to be, it says up here, less than 102. Not equal to it, just less than. And so that would be the correct inequality for that. And if we wanted to, we could actually find the dimensions of the couch as far as we could solve for W and find out what the width would be. We could plug that in here and then figure out what the length would be. Okay, but all it says is describe the dimensions of the couch you need to find, and we'll go ahead and stop at this point. All right, let's move on. We are going to do a few more problems of graphing and solving, and these are a little bit different because these are compound inequalities. They have an and in the middle, if you notice in the top one, or an or. And the way we represent them is a little bit different. Solving them, however, is the same. So in this case, we are going to solve for x, just like we would on the last one, by adding 1 to both sides. So we end up with 6 is less than or equal to 3x. And we drop the and down because it's still part of our equation. So we need to write the and. And then we have on this side still the 2x is less than 12. Okay, now we just need to divide both sides by 3. And we get 2 is less than or equal to x. And again, don't forget about the and, which is still in there. And on the right side, if we divide this side by 2 and this side by 2, we get x is less than 6. So the way to graph this is the same thing. We need to plot our points. In this case, we have a less than or equal, so we'll have a solid point at 2. I'll go ahead and make a solid point there. But on the right side, it says x is less than 6, not less than or equal, so we'll put in a open circle at 6. All right. Let's get those a little more on our numbers. Now we just need to figure out where to draw the line. Well, if you'll notice in this problem, it says we want all the x's, and again I'm going from the perspective of the x, to be greater than or equal to 2. So that would be to the right. And on this one we want all the x's that are less than 6, so that would be to the left. So what we end up drawing is a line that connects the both together. And what this means is that all of the numbers in between 2 and 6, including 2, are solutions to this compound inequality. We want all the numbers that meet this inequality and that meet the one on the right. Let's compare that to the one on the bottom that has an or. Okay, in this one, we're going to go ahead and solve for x again by dividing both sides by 3. And we get x is less than or equal to 1. We have our or in here. And on the one on the right, we'll divide both sides by 9. So then we get x is greater than 6. Okay, let's plot our points. On this first one, we have x is less than or equal to 1. So we'll put a solid dot at 1. And then on the next one, we have x is greater than 6. So on this one, we would want an open circle at the 6. Let's figure out our lines. We want all the numbers that are less than or equal to 1. In that case, those are the numbers that go to the left. If we look at the second inequality, we want all the numbers that are greater than 6. So in that case, we are going to want all the numbers that are greater or to the right of the 6. So now you can see the difference between the and the or. The or means that either this or this is true, but not both of them at the same time, whereas the and means that they're both true at the same time. Okay, let's move on. Again, let's look at writing some inequalities based on information that we have. In this first one, it says that Rachel's hair is at least as long as Julia's. So I want you to think about what that means in your head. Her hair is at least as long. So could it be longer? And the answer is yes, it could be longer. So we have an R for Rachel, and we have a J for Julia. So we need to figure out what inequality we would put in here. We wouldn't put in equals because Rachel does not have the same length hair as Julia. Rachel's hair is at least as long. So it could be the same length, but it could be more. Okay, so in that case, Rachel's hair is greater than or equal to Julia's. Now let's look at some wind speed. The wind speeds of tropical storms are at least 40 miles per hour, but less than 74. So in this case, we have a compound inequality. Let's just use W for our wind speed. The wind speeds of tropical storms are at least 40 miles per hour. So that means greater than, and I'm going to put the 40 on the left because it's smaller than the 74. Okay, we'll put the 74 over here on the right. So looking from the perspective of my variable, my wind speeds are greater than or equal to 40. That's what it says, are at least 40 miles per hour, but less than 74. Okay, and there is your compound inequality. All right, last slide. Let's write some inequalities. Let's practice doing that. So we have the graph already, and we want to write an inequality that matches the graph. In this first example, we have our x with an open circle here at -1, and we go to the left. So this is an easy one. We want all the x's to be less than -1, but not including -1. The second one, you know, is a compound inequality, so we know we have and because two things have to be true at the same time. In this first one, we have an open circle at 2 and we're going to the right. So we are going to say that x has to be greater than -2. Then if we look at our other point that we plotted at 1, again an open circle, and we went to the left. So x has to be less than 1. Okay, always remember that these points, these open circles or closed circles, are the numbers in our inequalities. And in our final one, this is going to be an or because they aren't the same, the solutions aren't here at the same time, right? We either have the solutions to the left here or we have the solutions to the right. So let's do our first one. And again, I always go from left to right, smallest to biggest. In this case, x is going to be less than or equal to -2. Notice that the circle is filled in. Or if we look to the right, we have that x is going to be greater than or equal to -1. And that concludes our instructional video on writing and solving inequalities. Go ahead and try the practice, and we'll see you on the next one.